In Lesson 2.2, you will be solving one-step equations. To solve an equation, it means you are finding the value of the variable that makes the equation true. Now, I know in some of these problems you might be able to look at the problem and know what the variable is equal to in order to make it true. But this is going to be one of those times where I insist that you show your work the way that I show in these examples here today, because if you learn the process on these easy ones, when we get to hard ones, they're going to be easy too. The first thing that you're going to do is you're going to draw the train tracks alongside the equal sign. The train tracks are just a visual to help you see the two sides of the equation. When solving an equation, the one thing that you have to always do is keep the two sides equal. And whatever you do to one side, you're going to do to the other side. Right now, if we want to get c by itself, we have to get rid of this minus 22 or the negative 22. And we do that by adding 22, because c minus 22 plus 22 ends up being just c, because the negative 22 and the positive 22 will cancel and become 0. And if I add 22 on that side, I have to add 22 on the other side as well to keep it equal. So over here, this minus 22 plus 22 is 0, and c plus 0 is just c. And over on the other side, 54 plus 22 is 76. Now, the nice thing about solving equations is you can check all of your answers before you ever turn it in. You check your answers by taking what you got and plugging it back into the equation to see if it's true. So to check it, 76 minus 22 should equal 54. 76 minus 22 is 54, so I know that we have the right answer of C equals 76. In our next example, we're going to start out by drawing the train tracks. We have 63 plus m equals 79. If we want to isolate m, or to get m by itself, we need to get rid of this 63. To get rid of 63, we want to subtract 63 from both sides. (63 minus 63 is 0. 0 plus m is just m. And on the other side, 79 minus 63 is 16. Now to check your work, you're going to take that and plug it back into here. 63 plus 16 should equal 79. 63 plus 16 is 79, so we know we have arrived at the correct answer. Example 3 is 2/3 q equals 1/2. Now our goal is to get 1 q left all by itself. This right here means 2/3 times q. Normally, to undo a multiplication problem, you would want to divide. But when we're talking about fractions, when you divide fractions, you really multiply by the reciprocal. So rather than write a division problem to then turn around and write it as a multiplication problem, let's right away multiply by the reciprocal of that fraction that's attached to the variable. So I'm going to multiply the left side by 3/2, and then to keep the two sides equal, I'm going to multiply the right side by 3/2. The reason we do this is because 2/3 times 3/2, 2/3 times 3/2 is 6/6, or just 1, and 1 times q is q. Or you could think of it this way, the 3's will cancel and become 1's, the 2's will cancel and become 1's, and 1 times 1 is just 1, and 1 times q is q. On the other side, 1/2 times 3/2, 1 times 3 is 3, 2 times 2 is 4, so q is equal to 3/4. Now to check your work, you would go and plug that back into the problem. 2/3 times q, which is 3/4, should equal 1/2. Well, 2/3 times 3/4 is 6/12, and 6/12 is 1/2, so we know we have the correct answer. In our next example, 39 equals negative 3r. Draw our train tracks, and this is negative 3 times r. To undo that multiplication, we are going to divide by negative 3. The divide sign we use when solving equations is the fraction bar. Now, sometimes kids mistakenly divide by 3 instead of negative 3 because they're so used to these problems up here where it's the opposite. Instead of negative 22, they do plus 22, and instead of a positive 63, they do negative 63. But down here, you want it to be the exact number that you have in front of the variable because our goal is to get 1r. And if we would just divide by 3, we'd have a negative divided by a positive, which is negative. And we don't want a negative 1r, we want a positive 1r. So we have to divide by negative 3. Negative 3 divided by negative 3 is 1, and 1 times r is r. And on the other side, 39 divided by negative 3, a positive divided by a negative is always going to be negative. And 3 goes into 39 13 times. So r is equal to negative 13. Now to check your work, plug that back in. 39 should equal a negative 3 times a negative 13. Well, a negative times a negative is positive, and 3 times 13 is 39. So we do have the correct answer again. Our last example says of a group of 13 to 15-year-old girls surveyed, 225, or about 9/20ths, said they talk on the telephone while they watch television. About how many girls were surveyed? First thing I would do is ask myself what I'm trying to find out. And I'm trying to find out how many girls were surveyed. So let's have G equal the number of girls surveyed. Now, if we go back and read the problem, it says of a group of 13 to 15-year-old girls surveyed, 225, or about 9/20ths, said they talk on the telephone while they watch television. So 9/20ths of the girls surveyed. 9/20ths of the girls would look like this. 9/20ths G. 9/20ths of the girls. That means 9/20ths times the number of girls. And they found that 225 said that they talk on the television while they talk on the telephone while they watch television. So 9/20ths G equals 225. Now to solve this problem, we're going to draw our train tracks to have our two sides. And just like in the example above, in order to get 1g, we're going to multiply both sides by the reciprocal of 9/20ths, which is 29ths. That will allow us to get 1g on the left. And if I do that on the left, I must also do it on the right side. So over on the left, I end up with just 1g. Over on the right, 225 times 20 ninths. I'm going to write 225 as a fraction by putting it over 1. Now to make this a little simpler math, I'm going to go ahead and simplify. I know that both 9 and 225, I know for sure that they can be divided by 3. I know they can be divided by 3 because the divisibility rule for 3 is if you add up the digits, 5 plus 2 plus 2, you get 9, and 9 is divisible by 3, so 225 is also divisible by 3. So if I go ahead and do that, 9 divided by 3 is 3. 225 divided by 3 is 75. Now, I actually know that I can divide by 3 again because 7 plus 5 is 12, and 12 can be divided by 3. So I'm going to go ahead and do that again. 3 goes into 3 once. 3 goes into 75 25 times. Now I'm going to go ahead and multiply 25 times 20. Well, 25 times 2 is 50, so 25 times 20 is going to be 500. So about 500 girls were surveyed. Now to check your work, you would plug this back in right there. 9/20 times 500. If you would do 9/20 times 500, you would end up with 225.